Welcome back to another video on the Physics Paper 2 topic of forces, and in this lesson we're going to look at Newton's first and second laws of motion. Before we start, remember the top tips for getting the most out of these lessons. Do not have any web pages or windows open that will distract you. Answer all of the questions. They will help to make sure you understand the new content. Switch off your phone, or at least have it in a different room. It's the biggest distraction you've got. And finally, try to complete the lesson in one session. It will really help you to understand what has been covered. The plan for this lesson, as always, we'll start with some retrieval practice. We know we need to go over previous topics to make sure we don't forget anything. We'll have a look at the new concept of Newton's first and second law of motion. You'll have some time to embed those new key concepts before it's your chance to have a go and develop your understanding with some practice work. What you're going to need is a mini whiteboard or a pen and some paper, possibly some revision cards for the retrieval practice, an exercise book or notepad to write down the new content, a mini whiteboard, pen and paper, or someone who can quiz you for the embedding, and an exercise book or notepad again for you to complete the practice work. Pause the video and get yourself organised. Let's start with some retrieval practice. First retrieval slide. Pause the video and answer the questions on some paper or on a mini whiteboard. Here are the answers. Any that you couldn't answer or weren't sure about, you should write down on revision cards or in a notebook so you can go back over them later. Pause the video and do that now. Second retrieval slide. Pause the video and give these questions a go. Here are the answers. Make sure you pause and write down any that you weren't sure about. And the final retrieval slide is to help you remember what has been covered in the previous lessons. Pause and have a go. Again, here are the answers. Pause and write down the ones you struggled with. On to the new content. You'll need an exercise book or notepad so you can write down the questions and answers as they appear on the screen. You will need these for the embedding part of the lesson later on. Pause and get yourself organised. You will already know about Newton's first law from work you've done previously on forces. So what is Newton's first law? A resultant force is needed to make an object speed up, slow down, or change direction. What happens to an object if the resultant force is zero? If the object is moving, it will move at a constant velocity. If the object is not moving, it will remain stationary. What happens to an object if the resultant force is above zero? The object will speed up, slow down, or change direction. On to Newton's second law then. What is Newton's second law? The acceleration of an object is proportional to the resultant force acting on the object and inversely proportional to the mass of the object. That's really complicated to remember, but there's an equation that we can use that's easy to remember. And what is the equation used to describe Newton's second law and to calculate resultant force? Force equals mass times acceleration. What is meant by the term inertia? Inertia is the tendency to remain in the same state of motion. And what is meant by inertia mass? It measures how difficult it is to change the velocity of an object. And we can write this as an equation, m for inertia mass. Now it's your chance to embed those key concepts. You can use the look, cover, write, check method, or get someone to ask you the questions and you can tell them the answers. Pause the video and do this now. Now it's time for you to practice using the concepts we've covered in today's lesson. Pause the video and open up your exercise book or notepad. First, I'm going to guide you through how to answer these questions. Copy down my workings as I go through them. I've got my questions printed onto a worksheet, but you can simply write them into your exercise book and answer them below if you prefer. Question number 1. How much force is required to accelerate a 0.5 kilogram object at 50 meters per second squared? First thing I'm going to do, reread the question and pick out all of the key information I'm going to need. First bit here, how much force? So it's asking me to work out F, and I've written a question mark next to F to remind myself that that's what I don't know. So how much force is required to accelerate a 0.5 kilogram object? So I have a mass of 0.5 kilograms at 50 meters per second squared. Meters per second squared tells me the acceleration. So A is 50 meters per second squared. What equation do I know that links these three? I know that F equals ma. And now I can substitute all of these values into this equation. So F is what we are trying to work out, so we'll stay as F. M is 0.5, and that's multiplied by A, which is 50. So 0.5 times 50, if I type that into a calculator, I get 25. So my force is 25 newtons. Remember your units. Newtons is the unit for force. Question 2. How quickly will a 100 kilogram object accelerate if it's being pushed with a force of 200 newtons? So again, let's pick out the key information. I've got a 100 kilogram object, so my mass is 100 kilograms, pushed with a force of 200 newtons. F is 200. So what do I need to work out? Well, it says how quickly will our 100 kilogram object accelerate. So I need to work out the acceleration, which is A. So the formula that links those, as we know, F equals ma. So my force is 200, my mass is 100, and that's multiplied by A, which is our acceleration, which we need to work out. I want A on its own over here. I've currently got 100 times A, so I need to rearrange. So I'm going to draw some lines down the side to give myself workspace. 100 times A, to get rid of the 100, I'm going to divide by 100. And I have to do that on both sides. So I have 200 divided by 100 equals A. So 200 divided by 100 gives me an answer of A being 2 meters per second squared. On to question number 3. What is the acceleration of the box? So I already know I need to work out A. So let's have a look at our box. We've got an 8 kilogram box, so I have a mass of 8 kilograms. And it's being pushed in this direction with a force of 13 newtons, but there's also a force of 9 newtons pushing in the opposite direction. So I need to find what the overall force for this box is, what the resultant force is. So in order to do that, I'm going to take 9 newtons away from 13. So my force is going to be 13 minus 9, which is 4 newtons. So now I've got a force, a mass, I can work out my acceleration. Using my equation, F equals ma. So 4 equals 8 multiplied by A. So again, I need A on its own. I've currently got 8 multiplied by A, so I need to rearrange. I'm going to do the inverse of 8 multiplied by A, which is divided by 8. Have to do that on both sides, so that gives me 4 divided by 8 equals A. So A equals, if I type that into a calculator, 4 divided by 8, 0.5 meters per second squared. And then on to question 4. What is the acceleration of the box? So again, I'm trying to work out A. I've got a 6 kilogram box this time, so I've got M equals 6 kilograms. And I've got an 11 Newton force and a 4 Newton force pushing in this direction and a 3 Newton force in the other direction. I need to work out my overall force, my resultant force. So my force overall, the resultant force, is going to be, well, I need to add these together, so that's 11 plus 4, and then I need to take away the 3 that's acting the other direction. So let's simplify that down. So 11 plus 4 is 15, and then take away the 3. 15 take away 3 is 12 newtons. So I've got my force, my mass, I can now work out my acceleration. F equals ma, force is 12, my mass is 6, and that's multiplied by my acceleration, which I need to work out. I need to rearrange to get a on its own, so I'm going to divide by 6 on both sides. 12 divided by 6 equals a, so a equals 12 divided by 6. If I need to type that into a calculator, I get 2 meters per second squared. Now it's time to practice independently the concepts that have been covered in this lesson. Pause the video and work through these questions. Here are the answers. Pause the video, check your answers, and make any corrections. Some more questions for you. Pause the video and give them a go. Again, here are the answers. Pause the video and make any corrections. That's all for this lesson. Make sure you go back over all the concepts from this lesson, including the retrieval practice, in order to develop your long-term memory. And I will see you next time.